guys, today we are going to do a lesson over equations with different amounts of solutions. The goal is after this lesson you should be able to solve equations with 0, 1, or infinite solutions. So let's get started. Okay, so first we have some examples. So we have 8 times x plus 2 equals 2x plus 16. So the first thing we need to do is distribute the 8 through the x plus 2. So we're going to multiply 8 times x and 8 times 2. So once we do that, we're going to be left with 8x plus 16 equals 2x plus 16. Now we need to get our variables, our variable on one side of the equation and our constant term on the other side. So I'm going to start by subtracting 2x from this side. And what you do to one side, you have to do to the other. So that'll cancel this one out. And we're left with 8x minus 2x, which will give us 6x plus 16. We still have that 16 there on that side. Equals 16 left on this side. Now we can get that constant term to the other side. So let's go ahead and subtract 16 from both sides, and that'll cancel this out. And we're left with 6x equals 0. But we're not finished. We can still keep going. So now let's divide both sides by 6. And our answer will be x equals 0. Now, for number 2. And it will help, guys, just a reminder, if you want to pause the video right there so you can catch up, go right ahead. I'm going to move on. Number 2. So, once again, we're going to distribute the 3 throughout x minus 1. And so that'll give us 3x minus 3, because we have to be aware of this negative sign here, or minus sign. And then we're going to have equals 2x plus 9. So once again, let's do our variables first. I like to get those on the left side, but remember I showed you guys yesterday in class that you can do it multiple ways. So I'm going to take negative 2x minus 2x. So that's going to cancel this side. And on this side, 3 minus 2 is going to leave me with just x minus 3 equals 9. I still have that 9 over there. Don't forget about that. Now let's get our 3, or our constant, on the other side. So we're going to add 3 to both sides. And we're left with x equals 12. All right, next slide. Okay, once again, we're going to solve some equations. So first, I like to combine like terms. So for instance, we have this 2x here and this negative 1x here. So I'm going to go ahead and combine those first. So 2 minus 1 is 1. So we're going to be left with x plus 7 equals, and on the other side we can combine the constants. So we can go ahead and combine this 4 and 3 right away. So on this side we're going to be left with x plus 7. Now, we need to get our variables on one side. So let's subtract x from both sides. That's going to cancel. And actually, look, this is going to cancel over here too. So we're left with 0. And really what we're left with is just the constant terms. So we have 7 equals 7. Another way you could look at that is, instead of doing the variables first, we could have subtracted the 7 from both sides, and we would have had zeros, and our final answer would be x equals x, and then subtract x from both sides, and your answer would be 0 equals 0. So let's do the next one. Let's go to the next one. Maybe this will help you see a little bit what we're doing. So first we need to distribute the 5 to the x plus 2. So that's going to give us 5x plus 10 minus 3x equals, and then we're going to distribute the 2 to the x plus 5. So we're going to have 2x plus 10. So combine like terms, we can combine this negative 3x and this 5x on this side first. So that's going to give us 2x plus 10 equals 2x plus 10. So let's start with the constants first. Let's get rid of those. So we're going to do minus 10, minus 10. It's going to cancel both of those out. We're going to be left with 2x equals 2x. So we can now, basically, we know right away that our answer is going to be 0, right? They equal each other. So when you have equations that equal each other like this, then you know you can come up with a conclusion. Your conclusion is when two sides of an equation end up the same, there are infinite solutions to the equation. So for instance, the first one was 0 equals 0. The second one is 2x equals 2x. Or we could have even left it 2x plus 10 equals 2x plus 10. So these right here, and you wouldn't have been wrong. The reason I showed you subtracting the 10 from both sides, is because I wanted you guys to see how they equal each other. So I just did one more step. But you actually could have stopped at 2x plus 10 equals 2x plus 10, and you would have been correct. All right, next slide. So, solve for the following equations. Once again, I'm going to combine my like terms on this side. So I see like a 1x plus 2x. So I know I got 3x plus 7 equals 3x minus 7. Okay? So I'm going to add my constant first. So plus 7, cancel this side. So we're going to have 3x plus 14, because of the 7 plus 7, equals 3x. Now let's get the variable on the other side. So I'm actually going to subtract this 3x and this from this 3x. So what you do to one side, you have to do the other. And that's going to cancel this. And let me move this down a little bit. And what we're left with is the 14 equals 0, essentially. Okay? So just keep that in mind. We're going to explain what that means after we do the next one. So the next one is, we have 4x plus 1. That doesn't change at this point. Now let's distribute the other side. 2 times the 2x and 2 times the 3. So that's going to give us 4x plus 6. Once again, let's do our constants first. Our constant terms, so I'm going to subtract 1 from both sides. Cancels this side, so we're left with 4x equals 4x plus 5. Now we can get rid of our variables. So let's minus 4x from this side and do it from the other side as well. So that cancels both of those. And what we're essentially left with is 0 equals 5. Because we have canceled both variables on each side, just like we did in the first example. Now, what does that mean? What is our conclusion from that? We can say when the two sides of an equation end up not being equal, then there are no solutions to the equation. No solutions to the equation. Okay, this last part, guys, I want you guys to solve on your own. So at this point, pause the video, try to solve these on your own, and then come back to it to see what the answers are. So, you've come back now, you've paused the video, you've tried to do these on your own. And please do that, because that is going to help you. Now, let's solve these. So we have I'm going to go ahead and combine my like terms that I can on this side. So I see 11 minus 7. So that's going to leave me with 3x minus 4 equals. The other side, I can combine the 6x and the negative 3x, or minus 3x. So that's going to leave me with 6 minus 3x is 3x plus 5. So see, I did some simplifying right off the bat, just to kind of make my equation easier. So now I'm going to do the constant terms. So I'm going to add 4 over here, add 4 here. This cancels. So we're left with 3x equals 3x plus 9. Now let's get our variable terms together. So I'm going to subtract 3x from here, 3x from here, and those are both going to cancel, leaving us with 0 equals 9, which means no solution. Okay? There was another way you could have done that. If you would have simply just gotten rid of the variables to begin with, you would have been left with, so say we did the variables here, and we would have been left with 4 equals 5. That's still going to give you no solution because they do not equal each other. Okay? All right, last problem. So let's first distribute the negative 2 to the x and the negative 5. So we're going to have negative 2x plus 10. Those two negatives multiplied together equal positive. Plus 10 equals, distribute the negative 3 to the x and to the 2. So we're going to have negative 3x minus 6 plus x. All right, now let's combine some like terms. So 10 and 10 can go together on this side. So we're going to have negative 2x plus 20 equals, and negative 3x and x can go together on this side. So it's negative 3 plus 1x essentially, which is going to leave us with negative 2x minus 6. Now, right off the bat, we could actually do the variables first. So we're going to add 2x to both sides, and that's going to cancel this, and that's going to cancel this. And so we're left with 20 equals negative 6, which once again is no solution. All right, that is our lesson for today. Thank you, guys.